Somewhere in a murky river, an animal longer than you are tall is about to release up to 860 volts through the water around it. That's enough to stun a horse standing at the water's edge. It's more than 5 times the voltage in the wall socket in your home. And this animal generates every bit of it using nothing but its own muscle tissue. This is the electric eel. And the way it builds, stores, and fires that voltage, without frying itself in the process, is one of the strangest pieces of biological engineering on the planet. The first thing worth knowing, the electric eel isn't really an eel. It's more closely related to catfish and carp, but it earned its name honestly, because roughly 80% of its body is dedicated almost entirely to generating electricity. Inside that body are 3 specialized organs, packed with thousands of modified muscle cells called electrocytes. On their own, each electrocyte is unimpressive. It generates a tiny voltage, something like 150 millivolts, barely enough to register on anything. But the eel doesn't rely on one electrocyte. It stacks them, 5,000, sometimes 6,000 of them, arranged one after another like individual cells inside a battery. And just like batteries wired in series, those small voltages add together down the entire length of the stack. The result? An animal that can generate over 600 volts at up to 1 amp of current entirely from tissue that started out as ordinary muscle. And the eel doesn't just have one setting. It has at least 2 completely different uses for this power system. Electric eels live in murky, sediment-heavy water where vision is close to useless, so they constantly emit low-voltage pulses, a few volts at a time, creating a weak electric field around their body. Anything that enters that field distorts it slightly, and specialized receptors along the eel's skin can detect that distortion. It's a form of electrolocation, similar in principle to how some fish and sharks sense the world, letting the eel navigate and detect prey in water where its eyes are nearly useless. Then there's the other setting. When the eel identifies prey or feels threatened, it switches from these gentle navigation pulses to its full high-voltage discharge, all 600+ volts, released in rapid pulses that can hit several hundred times per second. That high-voltage barrage does 2 things at once. It's strong enough to directly override the nervous system of small prey, effectively remote controlling their muscles into involuntary contraction. And research using electrode-equipped targets has shown the eel can literally force a hidden or fleeing prey animal to twitch and reveal its position before the eel even strikes. But there's a problem with generating that much voltage inside your own body, and the eel's solution to that problem is almost as strange as the shock itself. Researcher Kenneth Catania documented something extraordinary. When an electric eel confronts a threat at the surface, it will sometimes lift part of its body out of the water and press its jaw directly against the target, curling its body around it. This isn't random thrashing. Water conducts electricity far less efficiently than direct contact with skin. By leaving the water and making direct contact, the eel forces nearly all of its discharge directly into the threat, rather than dissipating harmlessly through the surrounding water. It's the difference between a diffuse shock and a concentrated one, and it appears to be a deliberate, targeted defensive maneuver, not an accident of anatomy. So why doesn't the eel shock itself into paralysis with every discharge? Its own vital organs, the heart, the brain, the electric organs themselves, sit in a relatively small, centrally protected region of the body, and the eel's nervous tissue appears to be comparatively less sensitive to its own electric field than the tissue of the animals it's shocking. The eel isn't immune to electricity in general. It has simply built its own anatomy around living safely next to a power source that would incapacitate almost anything else nearby. An animal made entirely of soft tissue, in water, generating enough voltage to stun a full-grown horse, and somehow not incapacitating itself in the process. And once engineers understood exactly how those electrocytes were stacked and wired, they saw something worth copying. Researchers studying the electric eel's electrocyte stacks have used that structure as the direct inspiration for a new kind of battery, one built from soft, flexible, gel-like cells stacked in series, mimicking the eel's own architecture rather than the rigid metal and chemical design of a conventional battery. The goal isn't to replace the battery in your phone. It's to power the next generation of soft, implantable medical devices. Things like pacemakers or sensors that need to sit inside soft body tissue without a hard, potentially damaging power source nearby. A power supply modeled on the eel's own tissue is soft enough and safe enough to belong inside a body in the first place. The electric eel didn't build any of this to help a research lab. It built a stacked, self-contained power system to survive in murky water where sight is nearly useless. And in solving that one problem, it became the blueprint for the next generation of battery technology designed to work safely inside the human body. That's the pattern on this channel. Nature isn't decorating the world, it's solving problems. Under pressure, over millions of years, with no room for a design that almost works. This eel didn't set out to inspire medical batteries or study human nerve conduction. It just needed a way to see, hunt, and defend itself in water where none of that should have been possible. And in solving that one problem, it turned its own body into the most efficient bioelectric power plant on the planet. Next time, we're looking at an animal that can climb straight up a sheet of glass, upside down, using nothing but its own feet, no glue, no suction, and a grip strong enough to hold its entire body weight on a single toe. That's the gecko. If you want to see the molecular trick that makes that possible, stay close. If this made you look at the natural world a little differently, you're exactly who this channel is for. Hit like if it changed how you see something you thought you already understood. Subscribe so you don't miss the next design nature perfected millions of years before we ever showed up. And tell me in the comments what you want broken down next. I read every one. This is designed to survive. We'll see you in the next episode.